Alright, in this video we are going to be going over Module 10, which is logarithmic functions. So Module 10 is broken up into 5 different lessons. So I'm going to go over each of these notes. These are the notes from Canvas. I'm going to go over each of these 5 lessons, and then I will work the homework at the very end. So as always, the homework questions that I work are the questions that are going to be on your test or your assessment. So that can be super helpful whenever you are studying for your test so that you know what to study with. So starting with 10.1, we are going to be converting exponential values. So it tells us that the logarithms are the inverses of the exponential equations or the exponential functions. There we go. So it tells us that the exponential function is f of x equals a to the power of x, or y equals a to the power of x. So I'm going to highlight these because these are helpful. And then right below it, it says the logarithm is that y equals log of a times x, or x equals a to the y power. Okay, so you can see that it's like we did previously. Whenever we were trying to find the inverse, we switched our x's and our y's. So that's what this is. So they tell us what we're going to be exchanging out. So there are some examples down here. We have that 3 equals log of 5 times 125. And if we were to write it in exponential form, it would be 5 to the third power equals 125. And then there's some more examples down here. Okay. That's lesson 1. Lesson 2, we are going to solve log equations. So a logarithm for all real numbers y and all positive numbers a and x where a does not equal 1. So this is the same thing that we just talked about. I'll highlight it again. Right below it, it says that the expression log of a times x represents the exponent to which the base a must be raised in order to obtain x. Whenever you see this, y equals log times x, it is a common log and it has a base of 10. Here they give us they give us a base, so a is our base. Y is going to be your exponent, and then x is what it equals to. Alright, so here they're just giving an example. They give us log of x equals, and they tell us that the base is 10. So this is, if you're just given this, it's a given that your base is 10. Alright, and then we're solving for the following. So very similar to what we were doing in lesson 1. So there's some examples that are down here. If you do not have a calculator with the change base key, then you can use the change of base theorem to find the value of a log with a base other than 10. So they tell us that if we have log of a times x equals log of b times x divided by log of b times a. So let's see what they're talking about. In this example, we have log of 5 times 17. We would take the log of 17 divided by the log of 5 equals 1.7604. And then it'll show you how to do this into your calculator. If you have a TI 83 or 84, it has these steps that you will go to get your log in your calculator. All right, that is lesson 2. For lesson 3, we're going to be graphing. So when you're graphing your log, look at these characteristics. Some of these characteristics that we want to look at, whenever we have that f of x equals log with the base of a times x, your points are going to be 1 over a, comma, -1, and then you've got 1, 0, and then a, 1. And then it just tells us if a is greater than 1, then f is an increasing function. If a is a fraction, then f is a decreasing function. Let me highlight these. It says the y-axis is a vertical asymptote. Okay, remember your asymptotes is what your lines are merging to. So each of these lines in this graph, they are merging towards the y-axis, which is our vertical line right here. And then it tells us that the domain is going to be 0 to infinity, and then the range is -infinity to infinity. So it tells us what the blue graph is, the red graph. So it just gives some examples. We have log of x, and then we have log of x plus 3. You're going to shift 3 units up. Whenever 3 is inside of our function, or the plus 3 is inside of our function, we're going to go to the left. Okay, here's some more examples. If we were to have a negative log, it would be a reflection across the x-axis. And then when we have a negative in our function, it's going to be a reflection across our y-axis. So these are kind of like our summaries that we had before, our graphing summaries. They're just all, they have graphs that go with them. All right, for lesson 4, to utilize properties of logarithms. So it tells us some properties. We have product property. Whenever you have log of a and then you have x times y, you can change it to the log of a times x plus the log of a times y. The quotient property, so whenever you have x divided by y, you're going to subtract. The power property, so when you have log of a times x to the power of r is going to go in front. So r times log of a times x. The logarithm of 1 is going to be 0. Base a logarithm of a. So if we have log of a times a, that equals 1. And then some examples that go through each of these properties. And then the last lesson is lesson 5. And so you're just going to, you're going to be solving an exponential or logarithmic equation. So to solve an exponential or logarithmic equation, change the given equation into one of the following forms. So they give us 3 forms. We have that a to the power of f of x equals b, and this is equivalent to a to the power of y equals b. And it says solve by taking logs on each side. Number 2 says log of a times f of x equals b. This says solve by changing to exponential form. A to the power of b equals f of x. And then the third one, log of a times f of x equals log of a times g of x, which is the same thing as, it's equivalent to f of x equals g of x. Number 4, in a more complicated equation such as this, it may be necessary to solve for a to the f of x or log of a times f of x, and then solve the resulting equation using one of the methods above. 5, check that each proposed solution is in the domain. So right below it, it says basically if you are giving log equations to solve, use comparable exponential equations. Make sure that the solutions are such that you have created positive logs. You cannot have a negative log. If you are given exponential equations to solve, use comparable logarithmic equations. Always combine as much as you can before you start. You can use either common logs or natural logs to solve unless e is involved, and then you must use natural logs. And then there's some more examples. And then there's one that talks about measuring the age of rocks. The homework for 10.1, remember, I'm only going to go over the questions that are on the test. So I'm not going to do number 1 or number 2. I'm going to start with number 3. It says to write in logarithmic form. So they give us this in exponential form, and we need to put it into log form. Alright, so I wrote this at the top, just what was from the notes, that y equals log of a times x, or x equals a to the y. So we can kind of see what's going on. So in this case, our x is going to be 25, because remember, we're using this, we're looking at the exponential form, and we want to put it into log form. So x equals 25. 5 is going to be a, our base, and then 2 is going to be y. So we get that y, which is 2, equals log with a base of 5 times 25. So log base 5 times 25 equals 2. Okay, so look out for that. So 3 is on the test. Number 4 is also going to be on the test. Again, they give it to us in exponential form, and we're converting it to log form. So in this case, we have some fractions. Don't let that confuse you. We're still going to follow the same rules that we are using up here. So we've got that y is going to equal -2. Our 3/5 is going to be the base a, and then 25 over 9 is our x. So I get that -2 equals log with the base of 3/5 times 25 over 9. So this particular one is multiple choice, so we're just going to choose the one that it is. All right. So number 3, number 4, number 5 is also going to be on the test. So this time they give it to us in log form, and we are converting it to exponential form. So we're working backwards. I'm still going to label these backwards, forwards, whatever. So log 5 is going to be our base a, 25 is x, and then 2 is y. So I've got 25 equals 5 squared. Alright, so 25 equals 5 squared. Alright, And I'm not going to do number 7. So that is all for 10.1. All right, 10.2, questions that are going to be on the test. I'm not going to do number 1. Not going to do number 2. Number 3. Solve the equation for x. And then we want to find what the solution set is. All right, so let me write this out. And then we will label. So this is number 3. It says solve for x. Let me scooch this up. And then we've got log of x 81 equals -4. So remember what we were looking at. X is going to be our base. 81 would be our x, and -4 would be our y. So we have 81 equals x to the -4th. And now we want to solve for x. So in order to get x by itself, we need to get rid of that exponent. One way that we can get rid of that is by multiplying it by its reciprocal. And I did a negative so we can cancel out our negative. Because if we have -4 times 1 over -4, those will cancel and we're left with 1. So I have x to the power of 1, which is just going to be x. So we end up with x equals 81 to the -1/4 power. So we're going to want to put this into our calculator. All right, so I'm going to do 81 and we'll use our exponent, and I'm going to do -1/4. Enter, and we get 0.33333. So let's do it as a fraction because they want it as an integer or a fraction. So I'm going to go to math, and then you've got a fraction, hit enter, and so we've got 1/3. So 1 divided by 3 would be our answer. I am going to do this one. So this is number 6. Let me scooch this back over. Number 6, we want to find the value, and we have log, and then we have 513 divided by 370. So our log is right here, and we've got 513 divided by 370. Enter, and it gives us as a decimal, and so it says round to 4 decimal places as needed, so it would be 0.1419. I'm not going to do that one. Number 8. I am going to do number 8. So it says to evaluate the following expression, do not use a calculator. So we have the natural log of e to the 2/3 power. So I'm going to pull up our properties from our notes. You do want to use your notes. It has a lot of information in there. So for natural logs, you have ln of x equals ln with the base of e times x. So your base is e. So if you look at the example for the natural log, whenever you have ln of e to a certain power, then x is going to equal that power. So e to the x equals e to your power. So in this case, x equals 2/3. So let me write that right here. So e to the x equals e to the 2/3, so x equals 2/3. All right, I'm not going to do number 9. I'm not going to do 10. Not going to do 11. I am going to do 12. So number 12, log with the base of 8 times 0.75. It says that we're going to use the change of base theorem to find our log. So the change of base theorem, let me scroll back up. Is it up here or is it down here? Okay, so log with the base of a times x equals log with your base of 10 times x divided by your log with the base of 10 divided by, log with the base of 10 times a. So we are going to divide log of 75 So let me write this out. So I wrote it out over here. So basically 8 is a, 0.75 is x. So we are just going to divide log of 0.75 divided by our log of 8. And we'll put this into our calculator. All right, so I'm just actually going to create a fraction, alpha y equals, enter. And so I've got log 0.75 divided by log of 8. And we get negative 0.1383. So negative 0.1383. All right, great. And that is the last one for, all right, 10.3 homework. So we will be having a question on your test like number 1. So I have pulled the notes up for 10.3, and some of these characteristics, they will be super helpful. So let me write some of this out. I'm going to do blue now. So this is 10.3 and then number 1, matching the graphs. So if you look at your notes, that first part, it says that whenever you have f of x equals log of a times x, so log of a times x, and then they tell us that it goes through the points. And so the points that it's going through is 1 over a, negative 1. So 1 over a, negative 1. Oops, 1, 0. And then also a, comma 1. All right, so they give us 6 different functions, and we need to match each function with its graph. So all of these look like they have a base of 3. So our first one, we just have log of 3 times x. Then we have log 3 times x. So our points, so 3 is going to be a. Okay, so a equals 3 on all of them. And then x is going to equal our x. So we've got, for our points, 1 over 3, comma, negative 1. And then at the end, we have 3, 1. So let's look at our points. We're not going to have any kind of reflection because we don't have a negative in our function. So it's going to follow the same characteristic of this red line right here, where it's coming from the bottom and then going up to the right. So, and we want to look that it has these points. So it's not going to be A, it's not going to be B, it's going to be, let's look at D. I think D might be too far up. It's not E. So F is going through the point 2, 1. E is going through the point 1, 0. Okay, so 3, 1 would be right here, so F is not going through that. 3, 1, so E is going through 3, 1, and then also 1/3, so it looks like E is going to be this, log. Alright, so I know that our base is still 3, but we have a shift. We have the -1. If you go to your notes for 10.3 and go to the bottom, it'll tell you like these shifts. Whenever you have x plus 3 in parentheses like this, it's going to go either to the left or right. So if it's a positive 3, it's going to the left. If it's a negative, it's going to the right. So we are shifting right 1 point. So this is pretty much going to be our like parent function for this second one. So instead of our points being these points, it's going to go to the right 1. So we would have the point 4/3 -1, and then also 4, 1. It's not going up or down, it's just going to the right. So again, it's not going to be A or B. And then we already chose E. I don't think it's going to be C because that was going through that point. So C, we have 4, 1. So it's not C. 4, 1. It could be F because 4/3 is like 1 1/3. So 1 1/3, and then -1 would be right here. So I think it's going to be F. Let me look at D. Okay, it's not D. So yeah, it's F. Because it's going through our point 4, 1, and then, okay. The next one we're going to look at is log of 3, 1 over x. So it's going to be helpful to us to kind of rearrange so we can see what exactly is going on. So whenever you have 1 over x, the x that is in the bottom, this can be rewrote as log of 3 to x to the -1 power. Anytime you have x in the denominator, it's the same thing as putting x to the -1. Now, if you look back at your notes, okay, so on your notes for 10.4, it has the different properties. For the one where x has an exponent, you can move your exponent to the front. So we can rewrite this as being negative 1 times log, which is just negative log base 3x. So if you look at your notes for 10.3, when you have a negative log, it's going to be a reflection across the x-axis. So I'm going to do our red. And so since it's a negative, I'm going to put x-axis reflection. So that means that our points that originally went through this 1/3, comma -1, and then 3, comma 1, those are going to be flipped over our x-axis. If you look at our options, there's only one that has an x-axis reflection, and that is B right here. Okay, our next one, we have log of 3 to the negative x, so it would be a reflection across our y-axis. So I'm just going to highlight our negative, and then I'll do the same thing. This is a y-axis reflection. If you look at your graphs, the only one that has a y-axis reflection is A. So both of these are going to be either like a stretch or a shrink. Now, I don't think it says it in the notes. It doesn't have this in the notes for some reason. But the 3x, when you're multiplying 3 times x, it is going to be a stretch. So let me put that. So we are going to stretch, and then the 1/3 is going to shrink our graph. And these are both the vertical stretch or shrink. So remember, our first graph was E, was just our like parent graph, log of 3 times x. And our point went through 1, 0. Since we are stretching it for 3 of x, that means our point is going up. So it's going up from 1, 0 to 1, 1. So that means that 3 of x goes to this one. And then we're shrinking on 1/3, so that means our point is going down. So that means that C is going to be this one. All right, so I know that these are a lot of work. You just have to honestly just write everything out. Or 5. So the only one that's on the test from 10.3 is this number 1, which is all right. For 10.4 homework, we are going to start off with number 1. Put this down. 10.4, number 1. Number 1 is going to be on your test. It says to use the properties of logs to rewrite the expression, simplify the result if possible, assume all variables represent positive real numbers. All right, so we have that log base 4, and then we've got times 5y over z. So if you look at your properties from 10.4, we are going to be looking at our quotient property. So anytime that you have x divided by y, you can subtract the x minus the y for the logs. So we have log, both of them will have base of 4. So we take 5y minus log of 4 times z. And then they also want us to simplify it further. So here we have the product property. So whenever you have the multiplying, you can add. So log of 4 times 5 plus log of 4 times y minus log of 4 times z. So log of 4 times 5 plus log of 4 times y minus log of 4 times z. So option B. Great. Okay, so number 1, and then number 2 also is on the test. So number 2, so same thing, we're going to use the properties to rewrite our expression, and we want to simplify it. So this time we have log base 4, and then we've got 6 times the square root of 10 divided by 5. Okay, so I'm going to start with our quotient rule, or our quotient property. So we've got log of 4, and then we've got 6 times the square root of 10 minus times 5. And then again, we have our product property. So log of 4 times 6 plus log of 4 times the square root of 10 minus log of 4 times 5. Alright, so our middle piece, we are going to continue to simplify this. So remember, your square root is the same thing as that number to the power of 1 over 2. So we can rewrite our square root as 10 to the 1 over 2 power. Remember also, anytime we have our exponent, we can move that to the front. So we have 1/2 log base 4 times 10, and that is what we end up with. 6 and then plus. So it looks like it's going to be option C. Alright. So those are going to be the only two from this homework that is on the test. That's not very bright. 10.5. Let's see. I'm not going to do number... Oh, I am going to do number 1. So number 1 is on your test. It says find an approximate irrational solution to 3 to the exponent power of 3 to the power of x equals 10. Okay, so we are going to use our log to find a solution. So I'm going to put log for both of these. So we have log times 3 to the power of x equals log times 10. So remember our exponent over here, I can bring it to the front. So I have x times log times 3 equals log times 10. I can solve for x by dividing both sides, and I get x equals log of 10 divided by log of 3. And you can put this into your calculator. So I'm actually just gonna go up and highlight this and click enter. And now all I have to do is change my pieces. So I have 3 on the bottom, and on top I have 10. I need to delete those two. Alright, so log of 10 divided by log of 3, enter, and I get 2.0959, because they want us to round to 4 decimal places. So 2.0959. Alright, great. Let me put on here to use calculator. Okay, so that was number 1. Number 2, I'm also going to do, so same thing, we're going to solve the exponential equation, express irrational solutions as decimals, correct to the nearest thousandth. So 2 to the x minus 4 equals 3 to the 2x. So if you look at your examples, they are using the natural log. So we are going to do our natural log of 2, and I'm going to go ahead and bring our exponent to the front. And then I've got the natural log of 3, and then I'm going to bring my exponent to the front again. Okay, I can simplify this one, so I can do x times ln of 2 minus 4 times ln of 2 equals 2x times ln of 3. Okay, remember I'm solving for x, so I need x on both sides. So I'm going to switch these out. I'm going to subtract this and bring it over here, and then I'll add this and bring it over. So plus 4 and then minus 2x. And so I get x times the natural log of 2 minus 2x times the natural log of 3 equals 4 times the natural log of 2. Okay, I'm going to factor out my x so that I'm left with the natural log of 2 minus 2 times the natural log of 3 equals 4 times the natural log of 2. And then I can divide this out to get x by itself. So x equals 4 times the natural log of 2 divided by the natural log of 2 minus 2 times the natural log of 3. So let's go ahead and put this into our calculator. Let me move this over. And I have 4 times the natural log of 2 divided by, and I'm going to put this on parentheses, the natural log of 2 minus 2 times the natural log of 3. And I get negative 1.84338. So to the nearest thousandth, so 10th, 100th, 1000th. So negative 1.843. Negative 1.843. Woohoo. All right, that was number 2. I'm not going to do number 3. So it says to solve our logarithmic equation and express all solutions in exact form. So I have log of 2, and then I've got x cubed minus 19 equals 3. So in this case, 2 is our a. This right here in the parentheses is our x, and then 3 is going to be our y. So if I was to rewrite this, I would get x cubed minus 19 equals 2 to the 3rd power. Okay, so I can now solve for our x. So 2 to the 3rd is 8. I need to get x by itself, so I'm going to add 19 to both sides, and I get x cubed equals 27. And then 27, if we were to be working backwards to find the cube root of 27, so what number multiplied by itself 3 times equals 27, x equals 3. So our solution set would just be 3. Okay. So number 8 is on your test. I'm not going to do 9. I'm not going to do 10. Not going to do 11. Number 12 is on your test. All right, this last one, number 12. We have the natural log of e to the x minus 8 times the natural log of e equals the natural log of e to the power of n. So all of them have the natural log of e. So I'm going to move 8 over to our exponent. So I got the natural log of e to the x minus the natural log of e to the 8th power equals the natural log of e to the 9th. Now remember that e to the y equals y. So, and I believe it's somewhere in your notes. It should be in your notes somewhere. Not going to look for it, but just e to the y equals y. So I can set x minus 8 equals 9. So we can solve for x. X equals 17. All right. So that is the last question that's going to be on your homework.